Determine where the rational function r of x equals x cubed plus 6x squared minus 4x minus 24, all divided by x squared plus 5x minus 14, is undefined. Determine whether an asymptote or a hole appears at such numbers. So we have our rational function r of x, and to begin, let's factor the numerator and denominator of this fraction completely. Using factor by grouping techniques, the numerator of our rational function will factor as the quantity x plus 2 times the quantity x minus 2 times the quantity x plus 6. The denominator of our rational function, x squared plus 5x minus 14, will factor as the quantity x plus 7 times the quantity x minus 2. So let's address the first question. What values of x will cause our rational function r of x to be undefined? Well, those are the values of x that will cause denominator to equal 0. So setting denominator equal to 0, we have the quantity x plus 7 times the quantity x minus 2 equaling 0, which implies that x is equal to negative 7 or x is equal to positive 2. So we have found two values of x for which r of x is undefined, x equals negative 7 and also x equals positive 2. Now let's answer the second question. Will we have a vertical asymptote or a hole in the graph at these two values of x equals negative 7, x equals 2? Let's first look at x equals negative 7. If we go back to the factored version of our rational function, we can see that the factor of x plus 7 does not get divided out. Therefore, at x equals negative 7, we will have a vertical asymptote. Now let's look at x equals 2. Again, going back to the factored version of our rational function, we can see that the factor of x minus 2 does get divided out. We have a common factor of x minus 2 in both the numerator and the denominator of this fraction. And because of that, at x equals 2, we will have a hole in the graph. So in summary, vertical asymptote at x equals negative 7 and a hole in the graph at x equals 2.